Hi everyone, let's solve today's Leetcode problem, which is problem number 2657. Find the prefix common array of two arrays. It's a medium problem. You are given two zero index integer permutations a and b of length n. A prefix common array of A and B is array C such that Ci is equal to the count of numbers that present at or before the index I in both arrays A and B. Okay. Return the prefix common array of A and B. In the sequence of n integers are called permutation if it contains all integers from 1 to n exactly once. Okay, so this is the problem that we are given two arrays and which will be permutation from 1 to n. Both the arrays will contain elements from 1 to n only, even in different permutation. And we have to tell the common array. And common array will be something till C of I is the number of elements that are common in both the arrays till index I. Okay, till index I, which means at that I or before. Okay, so A of A length, if we see it is A and B length can be up to 50 only. And which means whatever brute force approach we apply, it will work. And it is guaranteed that A and B are both a permutation of n integers. Okay, so this is the important thing for this question for optimizing. Okay, so the approaches that we are going to cover, there basically we are going to cover four approaches. One is the brute force, then optimizing it using two sets, then further optimization we will do using frequency array, and the most optimal approach here is using bit manipulation. Okay, so now let's understand the question a little better. So here if you see, so we have given this two array, and for these two array we know that this length can be only up to 50, and it is guaranteed that both are a permutation of 1 to n integers, which means both the array will contain elements from 1 to n only, and it will be only the different permutations, okay, 1 to n in these two arrays. So for the first case, if we see, so from for till if we find answer for, let's say, these indexes 0 1 2 3. So for 0 index 0, if we see, so here array 1 contains 1, array 2 contains 3. Okay, so there is no common so far. If you see, till here we saw in both the arrays there were no common elements, so answer is 0. Okay, now for index 1, if we find, so which means now we have to find till here. So here if we see, we have two common values. Okay, 3 is also there in both the arrays, and 1 is also present in both the arrays, which means the common count is now 2. Okay, now if we increase find answer for the second index, so here if you see, the already answer which we find for this one, that is 1 2 1 and 3, I mean those are already common, and another common element that we found, that is 2. Okay, so count increases to 3. Now for this one, if we see last index, so for last index, the already we had 3 common till here, and this one is again common in both the arrays, right? So answer is 4. And also one more thing to notice, that the this last answer for this last index, right, it will be always the count of the number of elements in this array, because as question itself states that number of elements in both the array will be from 1 to n only, and each element will appear at least once. Okay, so which means in total, if we see in both the array, total number of common elements in both the array will be n only, right? Because it contains all elements from 1 to n, both the arrays. So here it will be n always, okay, for the last element. So this is what the problem is given to us. Now let's try solving this using brute force. So brute force is basically finding answer for each of the index. So we have to, let's say, find answer for each zero index. So what we will do, so we will start finding. So C of I, which means our answer of I means that number of common element till index I or before, right? So now if we see for this index, for now we are finding for an index 0, right? So array of 0, this first array contains value 1 and second array contains value 3, right? So for this one we have to go till this only, basically till this index only we can find, right? The number of common elements we can find till here only, right? Because we are finding answer for 0. So for this one, when we find till here, there was no common, so we added answer as 0. Count was also 0. Okay, now when we increased our now we have to find answer for this one. Okay, so we will keep updating this count for finding answer for all of this. So initially it was 0, now again it is 0. Okay, now for 0 index 1, when we find, right, so for index 1 we know that we will start with this one. Okay, now we will go and see. Okay, if 1 is there, no. is 1 is there, and till when will have to find, we have to find till index 1, right? So we went till here and we find that okay, 1 was here, so we can increase the count, that okay, count common count is 1 now. Okay, now here also for this array, first array, we can find the elements in array B till index 1. Okay, so for 3 we will start searching, we find this 3 here itself, so we can directly break from here, no need to search till the first index. So we found that count to be we found one more element common, right? The second one is also common, so count is 2. So likewise we will update the count here to 2, right? Now we will find answer for the second index. So while finding the answer for second index, we'll do the same thing. We'll start our first pointer from here, and we will check if one is there, one is there. Okay, one is there, so it will again get, after first iteration answer was 0, after second iteration answer is 2. Now again we will make this to 0. Okay, we'll start counting again. So when we start counting again, we found this. Okay, what is the answer for this one? So 1 is here present, so count we will increase to 1. Now we will find 2 for 3, so 3 is also found here, so count now increases to 2. Now we have to find for 2, so when we iterated here, here, and then here, we found the count to be 2. Okay, so now count is 3. Okay, so 3 common element found so far. Now when we, so we check till here only, right? Because we are finding for the second index. So like we will keep on doing. So basically, for filling answer for each of these indexes I, we are going over this array till index I only, and checking for each of these elements in this first array into this second array, if that element exists till the index I or not. Okay, if it exists, then we can increase the count. If not, then we can leave the count as it is. Okay, so we are searching for this each index here, we are searching for this element in this first array into element into second array to find the number of common elements. So that is what we are doing here. Okay, so now let's check the code for this. So here n is array of size. We know that both of the array size are similar, and this is the answer array that we have created, and we are iterating over this n, right? So this is nothing but filling the answer array. Okay, so finding answer for each index. Initially our count is 0, which means we don't have any common element so far. Now we will find, okay, what we will find. So we will iterate on the first array index. Okay, and we will check if that array index is existing, and then we are iterating on the second index, right? Because for first array we are checking that element if that exists in the second array, so we are iterating on this every element of first array into second array, if we are and checking if the array first array element is equal to the second element. Okay, uh, in the second array, if it is, which means we can increase our count, that we found one common element, and then we can break because only one common element will be there, right? So we can directly break from there, and these both the values we have to go only till I. So we are finding for answer for I index, so we have to only explore till I. Okay, if we find the common element or not. So likewise we will keep on updating the count, and at the end we will keep pushing that count into our answer array, and then at the end we will return the answer. So yeah, that is the approach that we are going to follow, basically finding answer for each index. Okay, now time complexity, if we see, so this is one loop. Okay, then this is another loop. Okay, though this loop is going till index I only, but I can be at max n minus 1, right? So for that reason we can consider that this is also n, and this is another loop that is going till n. Okay, so time complexity is nothing but O of n cube. And space complexity, if we see, so we don't usually consider answer array into our count space complexity, because that is needed as part of question only to send, so we won't count that. So excluding that, and our space complexity is O of 1, because other than that we are not taking any additional space. So yeah, that's about the time complexity for this approach. Now let's see that every time we are going and finding, okay, we are just going and searching. Okay, for each element here we are going and searching. So is that really required, that okay, for each element we have to go and search all this sort of linear search and all? So we'll see that that is not really required, and how we can solve this using set. So using set, what we can do this, basically we can solve this using single iteration only, and we have these two set created, and for these two set that we have, we will keep adding our elements over here. Okay, So we will keep on adding, and what we will do, we will check, okay, this first these two element I have added. Now I will see if this one exists in the opposite set or not. So in the first set I will add elements from first array. In second set I will add elements from second array. Okay, now for common, for elements being common, this element from first array need to exist in the second set only, right? Because that contains elements from B. So if that exists, which means we have found a common array, right? So we will keep on doing that. We'll keep on adding these elements into these two sets simultaneously, and we will keep on checking, okay, if our if this opposite these values elements exist in the opposite set or not. If it exists, which means there is one common array common element that we have found. Okay, so let's do a dry run, then I'll explain more. Okay, so we started with this, and we will add these into both the sets. So set 1 contains 1, set 2 contains 3. Okay, now we came to this 3. Okay, and here we will be at 1. Now again, I mean, for the first one itself we will check, okay, if the 1 is there in set 2 or not. 1 is not there in this set, right? And for this 3 we will check if the 3 is there in this set or not. It was not there, which means our answer count remained 0 only, so we added 0 into our answer. Now we will check for the next index, that is this one. Okay, now we will add this 3 into first set and 1 into second set. Okay, so we added. Now this 3 we will check if this exists in second set or not. It exists in second set, it is there. Okay, so what we will do, we will increase our count by 1. Okay, now this one we will see if this exists in first set or not. This exists in first set, which means we will further increase our count to 2. Okay, and after this we will add this our 2 into count into our answer. Okay, now this is done till index 1. Now for index 2, what we will see that this 2 we will add these two in both the sets. Okay, now we will if we do the same way, right, basically checking if 2 exist in this set or not, second set, and here also 2 exist in this set or not. So we will end up adding 2 times count, right? But only one common element that we have found. Okay, so 2 is here, but if we see the number of common elements, it is 1 only, right? So if we directly do the same as we did before, in that way we will end up adding 2 times. Okay, so rather we will just check if this if both the elements are equal. Okay, which means we have found one more common element. Okay, so we will just add one count plus plus. Okay, otherwise if element in first array, I mean basically if it was not equal, then we have to check the opposite. Okay, first array and second array set or not, so like that. So since both are equal, we will just increase the count by 1 and we will add that into answer. Now again we will check for 4, so we will add the 4 into, if now since both are equal, which means only one common count is being increased, right? So for that reason we will add this count to increase this count to 1, sorry 1, which means it will be now 4. So we will add this 4 into our answer. So that is what we are going to do. Now let's check the code for this. So same thing, answer array we have n as array dot size, and when we have the running count. Okay, so this is running count that we have. Now we have two sets, set 1 and set 2, an ordered set that I have kept, and we will iterate over this array and we will find our answer. Okay, so first step was inserting both the elements into two different sets that we have. So we did that here. In S1 we inserted A of I, in S2 we inserted B of I. Now first step is checking if both the elements are equal. Basically for that we need to increase the count only once. Okay, so we increase the count by 1, and if both are not equal, so here when answer was let's say 3, so when first time we saw this, right, so this was first array, this was second array. So first time when we saw basically at index 0, so these two are not equal. When we checked into set also, right, this element didn't existed in different sets, right, which means there was no common array after so far. But when we came to this index 1 and we checked for this value, and when we find the in opposite set that 3 existed, which means that there is one common element which is matching with this one. Okay, and there for this one basically for this 3, and for this one I see that there is element in the opposite set which existed, which means there is another common element. one matching with this one, another matching with this one. So in that way we found two common element. But okay, so if those are not equal, then we have to check for every time if the other set contains or not. If other set contains, which means we have found. If it doesn't contains, which means we have not found. Okay, so yeah, that is that. So if it doesn't, if it contains opposite sets, so in first set we are searching for b of I, if it exists or not. If it exists, then we increase the count. In second set we are searching for this first a of I. Okay, if it exists or not. If so, then we are increasing the count, and then we are increasing that, adding that into our answer. Okay, and at the end returning the answer. So yeah. Now, if we see the time complexity, so this is nothing but iterating in one loop. That's all that we are doing, and nothing other than that. And the insertion, set insertion operation and other things, those are, this is unordered set that will be O of 1 only. So time complexity is nothing but O of n. And space complexity, if we see, so we have taken two sets, and each can contain, each will contain all the elements from 1 to n. So it will be O of n plus n, basically 2 of n. Okay, so basically we are taking two sets for this. So yeah, that's about this approach using set. So now if you see, we are taking two set, right? But to further optimizes that, is that really required? Because our elements that is there, it will be from 1 to n only, and that will be in both the arrays. Okay, so now if instead of that, if we keep the frequency array, right? So and we keep on updating the frequency, since both the array will contain I mean 1 to n elements, right? So altogether two times this frequency can be at max 2, right? Either it will be 1, I mean while running, and at max it can be 2, right? So we can use the frequency array instead of keeping two different sets, and we will follow the same thing, okay, what we are doing it. So now let's check that. So just using one frequency array, same as above, but we'll keep one frequency of size n plus 1, and because our question guarantees that number of elements are from 1 to n only, and that is in the both the array. Okay, so we will keep updating the count and checking accordingly. Okay, so let's see how we will do this. So this is how the frequency array will look like, and since the elements are from 1 to n, so we will represent this in terms of index, their values in terms of index, and we will update that their frequencies. Okay, so for that reason, this frequency array need to be is of size n plus 1. Okay, because we have to represent this value n also, right? So for that reason, we need to increase one size. Okay, now what we will do, we have this frequency array initialized as 0 initially. We will keep on iterating, and we will check, okay, if this same checks as above. So first thing we'll check, first thing is we'll update the frequency. Okay, as we were updating the set right there, so instead here we'll update the frequency. So we found 1 and 3, so for both of them we'll increase the frequency. Okay, so 1 and 3 we have updated the frequency. Now after that we need to check if both of these that we are checking, if both of these elements are same or not. Because if they are same, we learned above the right that we need to count only one times, so we would be increasing count only once. But since they are not same, so we will check if the frequency of this value is equal to 2 or not. If it is equal to 2, which means we have found the common array. Okay, count can be only 2 if we have found element from both the arrays, then only it can be 2, otherwise it cannot be, right? So what I will do, I will check if this count is 2 or not. So it is not 2. For this 3, I'll check for this 3, count is again 1, it's not 2, which means that our count is not increased. So our answer is 0. Okay, so we can keep here the count variable. Okay, now here again we will check for this 3. Okay, 3 and again 1, so again we will update their frequency. So this will be 2 and this will be 2. Now again, first check is if both of them are equal or not. So they are not equal elements. Now since they are not equal, we need to check if this 3 has the frequency as 2 or not. So here we see that 3 has frequency 2, which means it has found the common in the other array, right? That's why how frequency can be 2. So for that reason, we will increase our count. So initially count was 0, we increased it to 1. Now we find this first array. For 1 also we will check the same thing. If the frequency of 1 is 2 or not, it is 2, which means we have found the common array, common element in the other array. So we'll increase the count by 2. Okay, so count is now 2, we'll update this. Okay, so now we will check for, so we are done with this first index. Now we'll check for the second index. Okay, now for second index we see that both the elements are equal, which means we can directly increase the count, that we have found the common element. So count will be 3, we updated 3. Again for this 4 also we see that the count is I mean the elements are equal, which means there is a common element, so we can increase the count, and so do here. Okay, so that is what we are going to do it. Same as above approach. Basically logic is same, but instead of using two different set, we can use a frequency array and check based on the count wherever it is getting as 2. Okay, so let's check the code now. So here we have frequency array of size n plus 1, and the same above, like answer, size and all that, and running count that we have, okay, initially as 0. Now we are iterating over this array, and we are updating the frequencies as above. We are updating the set, so frequency of array of I we are updating, and b of I we are updating. Now here we are checking if, so I think one more thing I missed here, that when we found 2 here, right, we had to update the frequencies also. So here, from here we updated, for this 2 we updated the 1, and for this 2 also we would have updated it to 2, right? And same goes for 4 also, it would have been to 1, and then for this 4 it would have been updated to 2, like that. Okay, but since they were same, we don't really needed to check the their frequencies. Okay, so yeah, first check was if both we have updated the frequencies. Now we are checking if both are equal. If they're equal, then we have to count only once. Otherwise we will check if frequency of array of I is equal to 2 or not. If it is, which means there is a common element in other array, so we increase the count. And if frequency of b of I is equal to 2 as well, then we can again increase the count. So after this, our count will be updated once, and then we can add that count into our answer and then return the answer, same as above. Okay, now if we see the time complexity, again same thing as above. Time complexity is O of 1, since we are just iterating over a loop, and we are taking this frequency array that is of size n, no 2 times, so it is just O of n. Okay, so that is a, this one is a little slight optimization from the above approach, where instead of using 2 set, we are just using 1 set. Now let's see the most optimal approach for this problem. Okay, and that is using bit manipulation. Now the thing is, how can we think of bit manipulation in this problem? Basically this question itself says that elements are from 1 to n only. Okay, and it is less than 50. So definitely when it is less than 50, which means if we represent this every element in terms of bit, so if for long we it has 64 bits, right? So which means we can store these elements in terms of these bits and do something, right? So basically it says that all elements from 1 to n are present, and n is less than 50, we can represent these in terms of 50. So that is how we can think this question in terms of bit manipulation. Okay, that this is a possibility that maybe we can optimize in space. Okay, because bit manipulations there we don't really need some any kind of space as above. Okay, so what we will do, we will represent each elements in terms of bits, as in long it has 64 bits. Okay, and every number appears exactly once, so that is why we will be able to do that. Now we will use two different masks. I kept it as m1 and m2, and we will store the elements that we have found so far. Okay, so we will keep on adding those elements that we have seen so far. So how can we represent these numbers in terms of bits? Okay, so I'll do a quick dry run to make you understand. Now I have to we know, right, that this number can be only up to 50, right? So if I represent this number in terms of bits, so let's say it is 000 something something 000, right? So this is nothing but 64 bits, which is 1012 up to 63, right? So these are the bits. Now let's say if I represent this particular bit as number 1, this particular bit as number 2, and some bits here as number some x. Okay, so like this I will keep representing these. Okay, now if I have to uh, kind of set this bit representing the number 1, right? Which means so what we are doing, we are taking two masks, right, m1 and m2, and we are storing all the numbers seen so far. So if I see 1, how can I update mask 1, making sure that I have seen 1? Which means if this is my mask 1, if I make this bit set that will represent, right, that this one has been seen. So how can I make this bit set? So we you might already know about this left shift operator. If we left shift this operator by 1, which means this bit will be set, right? I mean, if we do this value OR, so this is my mask 1. If I do OR with this value 1 left shift by 1, we will be able to get this, right, with this bit particular bit set. So same way we will do, basically we will keep on masking these things. Okay, so now we will do a dry run, and once we got both the mask, so when I have both the numbers, right, something like let's say this, and 1 0 1 0. Now what is the common? So these represent 0 1 2 3, right? And if both the array would have contained 1 so far, which means both of these bit will be set, right? Now to know if both the bits are set, we can do simply AND, right? So because AND will give me 1, on other places it will be 0, because this represent that first mask, I mean first array don't have this value 3, but second array has this value 3. But in this index 1, if you see, both the arrays has this value 1, right? So that is why after doing AND we got this value. Now since we got this value, the common bits, I would say, this number. So in this number, if I check the number of set bits, so in this number of set bits are 1 only, which means there is only one common element that is found so far. So that is how 1 is there. Now let's do a quick dry run. So we found this value 1 and 3. So here we will mark this 1, and here we will mark this set bit. Okay, now after setting this bit, we need to do AND of these two numbers. So if we do AND of these two number, which will be 0, okay, which means that there is no set bit, so we don't need to increase our count. And number of set bit, if I count here, so it is 0, so we'll add that to our answer. Now what we will do, we will in the first mask we will update this 3. So if I update the bit of 3, and here also if I set the bit of 1, right? So like this. Now if I do AND of these two numbers, so what that is 1 0 1 1 0 1 0, both of this m1 and m2. Now after doing AND, I get it as 1 0 1 0. So this is my common bits. Now here what I can do, I can find the number of set bits. So here number of set bits are 2. Okay, so that is my answer. So I added 2 into my answer. Now I will check for 2. Okay, so again I'll set these bit 2 in both the mask. After setting the bit 2, I will check if both the I will do again AND of these numbers. So like this, 1 1 0. After doing AND, it is like this, and this is my number of common bits, I would say, the common bit number. And here if I check the number of set bits, so number of set bits are 3. Okay, so like this I will add the answer as 3. Now after in 4, we'll again set this bit 4 here. After updating this value 4, again if we do AND of these two number, it will be again 1 1 1 1 1. And after checking the count number of set bits, it will be 4. So like this we'll update the answer 4. Okay, so that was the as simple approach as that. Basically the important thing was, every time we are storing all the number of elements seen so far, and that we are doing using the OR, as I explained, that a number is there, and if we do OR with one left shift of this number of I, let's say a of I, which means that this is the number that is going to represent this number, right? So if I have to set this fourth bit, right, and this array of 4 means you have to set the fourth bit, right? If I left shift this 1 to 4, which means number would come something like 1 0 0 0 0, right? Yeah, this is 0 1 2 3 and 4. This is the fourth bit that I want to set, right? So for setting this bit, if I do one left shift of this 1 times, so this is how the number would look like. And if I do mask with my existing number, so this is nothing but doing OR, right? Basically we are adding that value, so doing OR will add that value into our number. So yeah, that is how we are doing. And then doing AND will tell me the number of common elements, and then I can count. So yeah, now let's check the code for this. So we have this n as array.size and this answer array. Now we have taken these two masks as m1 and m2, and since number can be till 50, so I mean normal integer represents till 32 bits only, right? uh, I mean, so for that reason we needed 64 bits, right? So for that reason we took this as long. Okay, now we are iterating over all of the elements, and we are adding each elements from array of I into mask1, array of B into mask2. Okay, so here we need to do one LL because this is a long operation. So doing this left shift a of I times, and we are doing then OR of that. So basically adding that particular, storing that particular element into this mask, and after that we are having this common bits variable. We are storing the AND of this M1 and M2, which will tell me the common bits in this both of the mask. Now we can have the common count calculated using this C++ STL, that is built-in pop count LL. So this built-in pop count LL gives me the number of common, number of bits that are set in this variable common bits. Okay, in 64-bit, that is using long. Okay, and we got that number of common bits every time we added that into our answer, and at the end return that. So that is what the approach looks like for bit manipulation. And with this we definitely are using some variables, so altogether space complexity has been reduced to O of 1, right? Now if we see the time complexity, so this is the one loop that we are running, so O of n. Okay, so formally, we consider the time complexity for this particular operation as O of 1 because it iterates on these bits, right? So that bits, number of bits can be O of 64, right? So that is what it is. It will take this much time. Since our constraint is low, we can say, I mean, sort of that it is O of n square because, but it is not really O of n square because this is constant, right? Every time it will go to take 64, it is going to take 64. Iterating over the 64 bits only to check if the bits are set or not. Okay, so we can say that, but usually we consider this as a common, so that is why I'm considering that as O of 1 only. And if more formally if we write, so it is O of n into 64, right, again, which is constant, so we can write it as O of n. So for that reason I've written it as time complexity as O of n only. Okay, but though the case is different, let's say this number would be something greater than 64, 50, we couldn't have applied this approach at all because we couldn't store this in terms of elements that we have, right? So yeah, but more formally if we say, we consider this as a constant, so for that reason time complexity is O of n and space complexity is O of 1. Okay, so that's all about this approach. I hope you like this video. Thank you for watching. Stay tuned for next videos.